Hello, everybody. This is lecture 1, and the topic is Introduction to Assembly Language. So, the first question is, what is assembly language? The assembly language is a machine level programming language that can be understood by human. It's the lowest level language close to machine code. As you can see from this figure, let me add some note, okay. So from this figure, in the first layer, we have the hardware. It is where the motherboard and the CPUs and the peripheral are connected together. And the next level is the machine language, shown by yellow. And this the blue one is the assembly language that we are writing our code. And then we have the high level programming languages at the top, languages like C program, Pascal, Fortran, object oriented program, and visual languages like Visual Studio, Java, and so on. So as we move up from down to top, the level of complexity goes down. So it means that in terms of understanding the code is somehow close to English language, and it is easier to understand, but it is get away from machine language. So, and that's the classification. So as we go up from bottom to top, so it is more readable for us, so we can understand the program more easily. But as we go down, we are closing to machine language, and the code like 0, 1 or hex code that sometimes doesn't make sense to a human. All right, so our focus in this course on the blue box, the assembly language. So we are using syntax and command that directly converted to a machine language of opcode of hex or binary. So we'll see more of this in this course. So the question you might have is, how many assembly languages are there? So since the assembly language are hardware platform dependent, so we have many different assembly languages. For C programming or C++, there are going to be only one. So they're going to be kind of a hardware and platform agnostics. But assembly language, the way that we write it, we need to know what the hardware is and how those registers are formed. Are they 16-bit register, 32-bit registers, or 64-bit register? And what is the category of the processor? Is it ARM processor or it is x86 architecture processor? So it depends which processor you're writing the assembly for, and that determines how to write the code. If it is still unclear for you the number of assembly languages we have, don't worry about that. We're going to talk about it more in the next few slides. So the second question that you might have about assembly is that why we bother even writing the assembly code where there are high-level languages like C, C++, or Java available to us. So the first reason is that we can't always use the high-level languages. to write our program. One is that sometimes you need to write the device driver, right? You need to write device driver, and for this device driver, you need to use assembly code. So if you want to access bits and bytes, then that's the way to go. So using Java, you might not be able to access bits or bytes, right? So this is one of the reasons. And the other reason is that sometimes you write C code and you would like to write more efficient program in it, and you would like to directly include assembly code in your C code to make it more efficient. So in that case, you also need assembly programming. Reverse engineering is something else. So once you have a system, so that all those opcode are in a machine level languages, then you take out those codes and then you convert it into the assembly, and it is where you need to understand the assembly code if you want to reverse engineer the system. And the other reason is writing more efficient programs. So when you are dealing with the hardware, when you are writing the code specific for the hardware given, your code going to be more efficient if you are professional in this field. So system programming is the other reason that we write, assembly program. So when you're writing code for firmware, or you are connecting different hardware together, then the assembly program are more efficient than the high-level languages like C. All right. So these are the main reasons, and we move to the next one and talk about x86 architecture assembly. So since we are using a computer desktop, and this desktop all have x86 architecture CPU processor implemented in them, the focus of this course is on x86 architecture processor. I would say about like maybe more than 80% of the CPU processor are x86 architecture. That's the reason I decided to have this assembly course on this class of CPU architecture. The other CPU architectures that are very common out there is ARM processor that they are being used for embedded system. All right, so these are the two main class of CPU architecture in summary: x86 architecture and ARM architecture. So for this course, our focus in x86 architecture because about 80% of the CPUs are having this hardware architecture. If you take like embedded system course, the focus most probably gonna be on ARM processor because those embedded system they are using the ARM processor. For example, smartphones or the different appliances that you have in the kitchen. Normally they have x86 architecture because they are more compact and they are more energy efficient. Okay, in terms of like the appearance of the code, we have two main category of assembly language. So we have AT&T architecture, syntax, assembly syntax, and we have Intel syntax. The focus of our syntax, the appearance of the code that we're writing, is on Intel syntax. So if they ask you, okay, how many assembly language do we have in terms of the appearance of the code and code composition, so we have only two of them, Intel, and then we have AT&T assembly syntax. And then for each of these, we can use this kind of syntax and comments to write assembly code for many different hardware platforms, including ARM processor, x86 processor, and so on. So in summary, we have two different code composition for assembly. One is AT&T and the other one is Intel. So our focus in this course is on Intel syntaxes. And this is because this is more commonly used in industry now. Okay, let's talk about the assembler now. So what is an assembler? So when you have your source code and then you compile your source code, then you have like, source code written in C, you will use compiler like GCC, and then you obtain your executable so that you can run, right? So the tools that you use to compile those high-level language to executable, that tools include an assembler in it. We're going to be explaining where the assemblers are in this process. But as for the assembly code, we directly use the assembler to convert our assembly code to executable. So this is the process. So here is the assembler between the .asm and our executable file. So we use assembler to produce binary or executable from assembly codes. But if we are talking about high-level language, use compiler to generate executable. So within that compiler, then we have assembler. I'll be explaining about this process shortly in the next few slides. Okay, talking about assemblers, we have different major assemblers out there. For example, when you have your assembly code, you're going to generate your binaries. Then you have many options up there to do that, many tools to do that. So one of them that's commonly used out there is MASM, which is an assembler from Microsoft. And then we have other assembler, and the very common one that's used normally in industry is the NASM one. So our focus in this course is also on NASM assembler. All right, let's now talk about the backward compatibility of an assembly language. By that, I mean that if, for example, you write your assembly code for a 32-bit processor, right? And then in a few years, then 64-bit processor comes in. Does your code work on this new hardware? The answer to this question is yes. If you write assembly code for a 32-bit processor, it's going to work on 64-bit processor. But if you write your code for a 64-bit processor, it won't work for 32-bit or 16-bit processor because they don't have the capacity to handle it. So backward compatibility here for assembly language is defined like this. A program written for low capacity hardware can be run in high capacity hardware. So 32-bit program assembly can be run on 64-bit machine, but the reverse is not possible. If you write the code for 64-bit machine, it cannot be run on 32-bit or 16-bit processor machines. So the platform that we're going to be using in this course is as follows. So the hardware that we are considering is the 86 processor family. So we're going to be focusing on 32-bit machines. So the operating system is going to be Linux, the assembler is going to be NASM, and the C compiler that we're going to be using is GCC. It's a very widely used compiler for C. And the linker that we link different libraries and object files going to be the GNU linker, and the short form is LD. So these are the things. Our platform that we're going to be dealing with in this course. So these are the most commonly used in industry. That's reason I've chosen to work with this platform. Okay, how does an assembly code look like? If you install your Linux, and then you have a C file, assume that the name is input C, and then you want to generate, some assembly code from this C file, the process is very simple. So you can use this command in Linux, gcc-s, this is your C program, and then -o stands for the output, and this is your output1.asm, meaning that if you have your input C, you can generate this file from it using this syntax, and you don't need to directly write ASM for that file. So if you have C file, you can generate the assembly file from it. And I provided this COM and this Linux command for you guys to see how an assembly code gonna look like. So this one generates the AT&T form of assembly for your input. But if you're interested to generate like Intel look assembly code, you can use this command. So this is the command that you can use to generate assembly code with the Intel structure. So this is your input file, and this is gonna be your output file. We name it output2 so that when you generate these two files on the same directory, they are not the output for the second command does not overwrite the first one. You can try this in your Linux and let me know if you have any question or problem generating these files. Just try it for fun and take a look at the files using Vim editor or any other editor that you are comfortable with. This is also another command that you can, generate assembly file from a C file. That's it for this lecture. See you on the next video.